No, you're fine.
Not relative.
I'll probably do it there now.
I've been on crutches for over a year. Yeah, but absent helps a lot. Ever seen him crochet or duct tape? I don't know how she did it, but it works. Like dish rags or something. Oh, that's a really neat idea. Yeah. Should sell those on like Etsy or something.
All right, guys, so the only real data analysis we've talked about so far are what's called measures of center. So the whole point of this little group work is to see how that's nowhere near good enough. Right? What I really want to do is to be able to quickly summarize a large group of data, and we're going to actually try to summarize it in two numbers. One of them will be a center, and what wins is the mean. The mean kind of wins. We already know that the median sometimes is better, but the mean wins for various reasons. We want to add to that one other number. We've got to figure out how to measure that number. And first we've got to figure out what the hell is that number going to represent. And really the whole point is to try to get you to realize what the real difference is. So, because what do you get on number 1? 13 for everything, right? But I hope to God, now 13, all these analyses you did, that's not the data, that's analysis of the data. Are all the data values for each group the same? No. So part 2, would you say that each group of data is the same? No. Does that agree with what you found in number 1? No. The stuff you found in number 1 says all the measures of center are 13. In fact, what is it? And then number 3, I want to do the frequency distribution. That shows you how the data is distributed, right? And hopefully you got this. C is kind of special. C is what we call a uniform distribution. And you can maybe see why it's uniformly distributed. Everybody gets the same. What is the main difference then? Not the center. All the centers are right here. What would you say the main difference is then between all the groups? Data. How are they different from each other? The centers are in the same place. No matter which way you measure the center, it's freaking 13. But I can see the data is different. So if I just give that one number to somebody, I got a 13, that's not good enough to give me a feel for what the data looks like. And I don't want to have to give everybody all my data points to look at. I want to be able to summarize it. So one number by itself is not good enough to capture what the data actually looks like. The main difference, let me come up with what the difference is. The distribution, so how it all is spread out. There you go. Which one is the least spread out? The least spread out meaning A is the least spread out. I like it. So imagine having a piece of toast. And you put a big dollop of peanut butter in the middle. You guys with me? So that's your measure of center. A would be somebody taking and going and taking a little bit out of that and just put it on either side. And that's not, you haven't spread that out, right? So not evenly spread out either. The most, so this is definitely the least spread out because it gets away from its middle the least. Which one gets away from its center the most? Definitely D. Doesn't D have more data points further away from the middle? All right, so this other number that I want to talk about today and tell you how to calculate, it measures the spread of the data. So for example, whenever I give a quiz or a test, I expect this number to be around 11 or 12. And what that represents is the average distance to every data point from the middle. Let me say that again. Doesn't that sound like that should be what the spread is? How far the data points get on average from the middle. So if I had a data group that was 13, 13, 13 all the way through, the spread should be 0. Because how far away from the center does it get on average? 0. So which one gets away from its center the most? This one does. The distance away from its center is going to be on average the most, the biggest. So this other number, so I have one number that measures the middle, that tells me the center. And then I have another number that says how far away from the center do all my data points get on average. That's going to be what we call the standard deviation. How much the data points deviate. And the standard part of that is the averaging part. Standard meaning kind of like an average is kind of a standardization. Okay, let me stop there for a second. So that's what I hoped to kind of lead you towards with this little handout. Now let's talk about the math behind calculating this standard deviation. And yes, I am evil. I have people that retake statistics and they say, well, my last teacher let us push buttons and the number came up. I don't give a shit. But I'm going to show you what goes into it. I will tell you this. After this first test, you're never going to have to do all the work involved. We'll just get the number out of the calculator. But I'm not going to let you leave this class without seeing what goes into it. Not little black box hiding all the information. I like it. So let's take a look at, let's do group B, I think. Let's start with group B. Let me see here. So do me a favor, write the data like this. Find some, get some paper out. So group B, write it like this. So this is going to become our standard way of doing data. And you realize how this corresponds to the way the calculator does it. This would be like list 1 in the calculator. So we'll do this by hand first, and then I'll show you how to do it in the lists in the calculator. So again, if you want to borrow one, just bring your ID up and you can grab a calculator. So I am going to lead you a little bit. I'm going to have to lead you because this has already been established. But I want you to kind of go through the steps of why it makes sense. If I want to measure how far the data points get away from the middle on average, what would I have to calculate first to get that? So, yeah, the distance for... So if I wanted to take the average age, I'd first have to get all of the ages. If I wanted to get an average shoe size, I'd first have to get all of the shoe sizes. If I want to get an average distance from the middle, I'd first have to get all the distances from the middle. All right, so far does this make sense? Because I know I want this spread to be an average distance from the center. So in order to average something, I first have to have a bunch of values of that. Ages, shoe size, distances from center. So in symbols, the distance from the middle. And these are all, we start off with, let's assume for the moment, that these are all populations, right? So these are all classes. Now, this probably wouldn't be a class at Grossmont. We wouldn't let it run with 10 people. The state would say, we're not going to waste our money. Okay, whatever. But let's say those are populations. And normally people think population means in the millions. No, population could be 3. Right? So these are all populations. It's going to be different based on if it's a population versus a sample, and I'll explain why when we get to it. So the distance from the center for each of these would be x minus the mean. So one thing is, since I know it's a population, I'm going to use that mu symbol. What would I use if it was a sample? Who remembers? X bar. I love it. I love it. So we'll quickly see a problem develop. What is the mean again? 13. So for x, for 6 minus 13, negative 7. And then just keep going. Number 3. Notice something, I made these symmetric for no real reason other than that was the easiest way to quickly make them all have the mean of 13. I don't know if you guys realize all I did. If you start with nothing but 13s, that's an average of 13. Then if I make the first one go down 7 and the last one go up 7, it's going to have the same average because they add to the same number. Does that make sense? Yeah. And then I just kept doing that with the numbers in the middle. I took one down, took the other one up that much. Took one down, took the other one down, up that much. So I'm guaranteed that they all have the same mean. Okay, I like it. They don't have to be symmetric for the next thing to happen. Notice how this really, really sucks. I want you to guys realize. The mean is always going to be right in the middle of the values. Not the middle of the data points, but the middle value, meaning it's going to have equal parts negative as positive when I do this kind of thing. So how do I find the average distance? I would normally add up all the distances, and they're not distances yet. You can kind of argue that. But wouldn't this stupid thing add up to be 0 every freaking time? All right, so this is not good enough. This is a first step. One way we could take care of this. What is distance in mathematics? What do I have to use? In math, what do I use to get distance? Absolute value. That's always positive because it represents distance from 0. Now, I don't know if you guys remember this. What does an absolute value function look like? No, I'm sorry. Not the symbol, but if you graph it.
Like this.
Beautiful. It's like this. Right? I don't know if you guys remember a parabola for x squared would be nice and smooth. This would be, is this a plane you want to be in? You're dead. I mean, that's a lot of G's to make that kink little turn, right? So mathematically, this hard point, this sharp edge, sucks. So we're not going to use absolute value. It actually is used, and it's called standard error, but it's not used a lot. So one way, so everybody, I want you to realize the problem. These are all going to add up to be 0, always. So I got to make them not do that. So one way to do it is to make absolute value, but that has mathematical problems. It's got this sharp turn. And if you've taken any calculus, you might understand why that's a problem. If you haven't, don't worry, it's a problem. So what's the other way to make sure that things come out positive? Square. And again, that's the plane that we could survive. We're going to turn now, okay. Not, we got to turn, shit. So, I'm still recovering from my random out. We would take all those values and square each one of them. What does that mean I want to do at the end? Square root. Because right now, if my x's represent dogs, number of dogs people own, then right now at this point I got square dogs, or dogs squared, right? Some kind of Picasso looking, I don't know. Right, little cubic, little, I don't know what to do with it. Weird. So at the end I'm going to square root so all units become normal again. Are you guys understanding the reasoning behind this? I'm obviously leading this because I'm trying to go through a couple hundred years of development here in one class. Even 100 years, but decent amount of time. So if I square each one, 49, 9, 4, 1, 0, 0, and then just repeats. This is symmetry. So what we're going to do now is we're going to find an average squared distance and then take the square root. So here's all my squared distances. So to find the average, I add them up. And what symbol do we use in statistics for add them up?
Sigma.
Sigma. What is it? Austin Powers magma. So the sum of these, that's what we're doing right now. So it's really important when we start looking at a bunch of these formulas. You have to label the number you're calculating at the moment so you know where the hell to put it into the formulas. So what gets people down about stats is the concepts, the Greek letters, and which formula to use. So you want to be really nice to yourself and tell yourself what the shit you're doing right now. Right? Right now, I'm adding those up. Sweet. And of course, what do you get when you add those up? Does somebody do that for me? Who is it? 126. And again, reminding you, we're trying to get the average squared distance right now. So what would I do with that number I just got? No. Divide it by 10. I like it, right? So this number we're getting right now, let me give you the symbol for it. It's lowercase sigma. We're going to draw a couple of these just so we get used to it. Start at the belly, go out. We do it again. Like that. That's sigma. Whee! Right. I get people that eventually make it just an R, but it's got a little belly to it, right? It's been well fed. So So what we're actually doing right now is not sigma by itself, we're getting sigma squared, and that really is just to remind us that we still haven't taken the square root yet. So the average squared distance would be sum up the squared distances and then divide by how many there are. That's the formula for this. And before I take a square root, it actually gets its own little name. This is called the variance. In this case, the population variance. All right, let me slow down for a second. I'm doing this quicker than it was developed, obviously, but I want you to see why the logic kind of makes sense. So what do we get so far for this? Here's where people make their biggest mistake, and it's kind of our fault a little bit, because in algebra you get so used to putting things in for every letter. But this whole damn thing is what? 126. You don't put something in here. What does this represent? All of these, right? So there's not a single thing you could put in there. So this whole thing is the sum of these, which is 126. And it was 10. So what do we get so far? 12.6. And that's the variance. 12.6. And then how do I get this standard deviation? The symbol actually reminds me I still have to square root it. So you guys can help me out with that. Okay. So do me a favor, go 3 point and then just go for like 4 places. 5? 4? 9? 9, 6? Ooh, you're going to love this. Let's see if you can remember how to round. So always take standard deviation to at least 3 places. So if I wanted to take it to exactly 3 places, what would I have to make this? 3.55, I love it, because it'd be 550, right? Is that crazy? 9, 6. Hopefully that makes sense. So let me say this again. And whenever I say something real slow, that means it's an important note. Always make standard deviation at least 3 decimal places. If you don't, you lose points. And the real reason I make you do that is because about 3 decimal places is where the rounding doesn't hurt you. If you round something too early in a problem, your answer is going to be off. It's like being 1 degree off when you're in a boat. 8 hours later, you are lost. You guys are like, I don't know, I don't either, but you're going to be way off from where you're supposed to be. Yes?
Do we put 3.550?
Well, it's the same thing as that.
Okay,
Right.
like, you know.
So if you do, you're fine.
Okay, cool.
Yeah. Say again? Yeah, like I said, at least 3 places. So if you want to use 4 places, that's beautiful. Yes?
So, what is this like practically used for?
All right, so you ready? So first I want to make sure everybody was with me on the calculations. I need you, we are laying groundwork for, this is going to rule our life for a huge part of this course. And to make this make sense, if I had 2 teachers I was trying to decide between, and I don't know if you guys know this, I know you guys know that Rate My Professors website, right? Where nowadays, if I get a bad review, it's actually kind of a compliment sometimes. I don't know if you guys understand. But there's another website that'll actually tell you the grade distribution for teachers, which kind of sucks. Thankfully, you have to pay money to get into it. But it's actually public domain knowledge. So you can find a teacher that gives nothing but A's, take him, but then please don't take me after that. Because I'm gonna hate you a little bit. I'm like, come on, you don't know shit. So you should want the teacher that's going to teach you, not the teacher that's going to give you A's. There are teachers that give you fill-in-the-blank tests. I don't know if you know this. And that sounds so nice, but oh my God, no. Please, hopefully some of you guys realize that. But if I wanted to figure out which teacher to take, and everything else is the same about these 2 teachers, and they give like an average of a C, right? But one has a spread from A through F, and the other one has a spread from B through D. And let's pretend like we're at university where D is still passing. I don't know if you guys realize that. Yeah, so you could have a bridge made by somebody who had nothing but D's in all the courses. So don't freak out about it. So you guys kind of with me still? So they both give an average of a C, but the spread of one is A through F, and the spread of the other one is B through D. And I don't know if you've hit this teacher yet, but I had a teacher where they were waiting basically for some kind of a god to show up to give an A, right? The highest grade they ever gave was a B, and I'm like, because that was me, and I was like, give me the A. But, are you guys with me? So when would you take the A through F teacher versus when would you take the B through D? Is this valid information to know, the spread of their grades? Is it good information to know? Yes, because who do you think would take the A through F? Someone who knew they were going to kick ass in the course, right? And of course, who's going to want the B through D? Someone who's like, I'm going to suck in this course. I want to pass at least, and they don't give any Fs, so let me take that person. Are you guys with me? So on that level, that's an example of the spread of data helping you. Another level, you could have somebody that cuts wood. And they cut wood at an average length with a little bit of tolerance, a little bit of error. So standard deviation relates to error in a way, how much off you might be by. And that obviously is really good to know. If you're building something you don't care, they don't have to be that perfect. But if you have to be really close, you're going to find a company where the standard deviation is small. So they're closer to their average most often, right? Does that make sense? The other one might be cheaper, but the one that's better is more expensive, so you got to weigh all that together. But you got to know the spread to be able to make that distinction. Are you guys semi with me? Okay. It helps me out as a teacher because if I give a test or a quiz and I calculate the standard deviation to be 18, and I told you normally I'd expect to be 12, 13, a standard deviation of 18 tells me some people completely understood it and some people totally didn't understand it. Do you guys get that? Versus if I get a standard deviation of 8, that is stupid small standard deviation. That just means everybody basically didn't understand certain things, right? Everybody made in the 70s, maybe a little tight group of grades. Do you guys follow? So it gives me a quick way to interpret what's going on in the class. I like it. Okay, maybe. And trust me, the uses of this thing does not end there by a long shot. It's insane. So we got to develop a few more ideas to really see how much we can use this thing. So what I want you to do right now is to do everything we just did, but do it for group D. Should the number be bigger or smaller than this? Who did we say was the most spread out? Who did we say was the most spread out? D, please. Who gets away from the center the most? D. Which one did we just do? We just did B. So will D's standard deviation, since it measures spread, will the standard deviation for D be bigger or smaller? Bigger, because D's got a bigger spread. So do everything we just did. I love you guys giggling in the back here.
Sorry.
About 8 years old. Do everything we just did, but do it for the data from group D. It's all right. You'll develop.